Triangles. We are going to discuss triangles. There are different types of triangles. We have the isosceles triangle, we have the scalene triangle, we have the equilateral triangle, and lastly, we will look at the right-angled triangle. Now, in the right-angled triangle, there are three things that we need to know. The right-angled triangle has the base, the height, and the longer side, which is called the hypotenuse. In this lesson, we are going to discuss the Pythagoras theorem, where we will be looking at the relationship between the base, the height, and the hypotenuse. In our right-angled triangle here, we have the sides A, B, and C. A represents the base, B represents the height, and C is the longer side, which we call the hypotenuse. Now, let's look at the relationship that makes up this right-angled triangle. This area here, which is our base, we have 3 units by 3 units, which we can get its area by squaring the A. So 3 multiplied by 3 is the area of this square at this point here. The height has 4 units by 4 units. We can derive its area by multiplying 4 times 4, or rather 4 squared. And then our longer side is 5 units by 5 units. We will derive its area by multiplying 5 times 5, or we can say 5 squared. Now, this theory explains how we derive this bigger area by adding the square of the base and the square of the height. So let's look at this. If we take a squared plus b squared, which represents the height, should be equal to c squared, which is the hypotenuse. And by the look of things, we can do this practically. So we'll say 3 squared, which represents our base, plus b squared, which is the height, 4 squared, should be equal to c squared, which is 5 squared. So let's see if this is true. This will be 3 squared 9 plus 4 squared 16 should give me 25. So 3 squared 9 plus 4 squared 16. Now 9 plus 16 gives me 5 squared, which is 25. This is the basis of our lesson today. So we are going to look at examples on how we can use this relationship in solving mathematical problems. This is our first example. We are supposed to get the longer side of this right-angled triangle. So we have to remember what we said: a squared plus b squared should give us c squared. So in our triangle here, the base is a, the height is b, and the longer side is c. So what we have to find is the c. Then we will come here and do a substitution and say a is 6 centimeters, so square 6, plus b, which is 8 centimeters, square 8, should give us c squared. Let's see how this works out. 6 squared is 36, 8 squared is 64, should give me c squared. Now, 36 plus 64, this is a simple sum. This gives me 100 is equal to c squared. Anytime you get a situation where we have a value that has a square, then the other value here is a perfect square number, you just get the square root. So for us to remain with c alone, to make c the subject of our formula, we will get the square root of both numbers on both sides, the equal sign. So the square root of 100 is 10, while the square root of c squared is c. So we have our longer side, c, as 10 centimeters. Our answer will be 10 centimeters. So we now have our longer side c as 10 centimeters. So we'll have our c here as 10 centimeters. Now, you have to remember this all the time. Whenever we have a c squared, this is a perfect square number. The only way to get c alone is by getting the square root on both sides. So we did the square root of c squared to get c, and the square root of 100, which is 10. Let me take you through another example where we are finding the base or the height. Let's look at how to get the base in this question number 2. Our first step is to write down the theory. A squared plus B squared is equal to C squared. And then the second thing, we have to do the substitution. So we'll come here and say our A we have not been given, so A squared remains an unknown number. And then B squared for the height is 24 squared is equal to C squared, which is 25. So then we will work out A squared, 24 squared is 576, which gives me 25 squared, 625. So up to this point, we have to collect the like terms. In this case, 576 has to cross the equal sign to go to the other side. So we will have A squared is equal to 625 minus 576. Remember, this is a negative sign because on this side there was a positive sign. Now, A squared will be equal to 625 minus 576, which is 49. In our first example, we said, in this case here, what we need to do is to get the square root of both sides. So we'll get the square root of A squared and 49. The square root of A squared is A, while the square root of 49 is 7. So we can say that the value of A is 7 centimeters. The value of A is 7 centimeters. Now we have looked at two examples. The first one, we are supposed to get the longer side. The second example here, we have been discussing how to get the base. And now let's look at the last example, where we'll discuss how to get the height of a right-angled triangle when you have the hypotenuse and the base. So our first step, we are going to write down A squared plus B squared, which is C squared. So in this case, we are supposed to get the height, so we'll do the substitution. Our A here is 5, so we will substitute there 5 squared, but we have not been given the B, so the B remains unknown. Our longer side is 13 squared. So 5 squared is 25 plus B squared, which is equal to 169, 13 squared. Let's collect the like terms. 25 goes across the equal sign. So we will remain this side with B squared is equal to 169 minus 25. Now, 169 minus 25 gives me 144. So B squared is equal to 144. We want to make B to remain alone, so we will get the square roots on both sides. The square root of B squared is B, while the square root of 144 is 12. So our B is 12 centimeters. So the height here is 12 centimeters. Now, we have just looked at the three areas when we are trying to solve problems that involve right-angled triangles. So you have to always remember this area here is very important. A squared plus B squared is equal to C squared. And the last thing that you should always remember is when you want to get the unknown value, you have to get the square roots on both sides. In conclusion, the Pythagoras theorem states that A squared plus B squared is equal to C squared.